Hello students, today we'll be doing a problem based on Alembert principle. The question says the system of pulleys, masses and connecting inextensible cables as shown in the figure. Pulleys are massless and frictionless. If the system is released from rest, find the acceleration of each of the three masses and the tension in the cable. Now here the diagram which is given in a blue color is only given in the question. Now here the very first thing, as you already see, that block C is 6 kg, block B is 4 kg and block A is 2 kg. We'll start putting a tension in the string. So block A away from the block, T tension, away from the pulley, T tension. The same string continues, away from the block, T tension, away from the pulley, T tension. This 2T will be here, away from the pulley 2T, away from this pulley 2T. Similarly, this string continues here, so away from the pulley 2T, away from the block 2T. I hope you understood this. Now, what we will consider here is, as here the friction is not being considered, so what we'll consider that all the blocks, all the three blocks is moving down. That we'll consider. I know it is not feasible that all the three blocks will be coming down. 6 kg is more, so 6 kg will be coming down. What about this? We'll be seeing later. But for this particular problem, what you have to consider is all the three blocks are coming down. The answer will let us know that which block is going above and which block is coming down. So for block C, the acceleration is downward, AC. Block B, acceleration is downward, AB. Block A, moving downward, acceleration is AA. So by principle of virtual work, what it says, T into this T into delta XA plus T into delta XB and T into delta XC, but here T is 2 times of T. So 2T delta XC. This all are in the form of addition equals to 0. Why all addition? Because all the things are moving down. All the acceleration, all the blocks are moving down. Hence it is taken T delta XA plus T delta XB plus 2T delta XC equals to 0. Here if I'll take T common and 0 upon T, T will get cancelled, it becomes 0. And delta XA plus delta XB plus 2 times of delta XC. If I'll take it differentiation twice of it with respect to T, then it will give me acceleration of A plus acceleration of B plus 2 times of acceleration of C equals to 0. This will be getting, which is also to be said as a kinematic relation. This is my equation 1. Now what I'll do is I'll draw the FBD of each diagram, each block, and then we'll see how it works. So FBD of block A. FBD of block A, the weight is acting downward direction, that is weight A. Similarly, tension is acting upward direction, so tension. As we have assumed that the acceleration is downward, so opposite to that there is an inertial force which is MA. M of block A into acceleration of block A. We'll apply summation F of y, upward direction positive, minus WA, minus W as it is down, plus T plus MA equals to 0. AA is equals to, the W is what? It is mentioned here, 2 into 9.81. It is 2 kg. So 2 into 9.81 minus T as it is moving on the right side upon this M is having 2. I hope you understood this. AA is equals to, when you solve this, you will be getting this 9.81 minus 0.5 T. That is the equation 2. Let's see the second block, which is block B. Block B, weight is acting downward direction. If you see here, weight is acting downward direction, T is acting above. We have considered the acceleration down, so its inertial force will be also above. So we will see here, weight is acting down, T above, inertial force above, acceleration is downward direction. So if I'll apply summation F of y equals to 0, upward direction positive, minus WB plus T plus MB AB equals to 0. So AB is equals to what? WB. WB is how much? For this it is 4 kg. So 4 into 9.81 minus t upon 4. Upon 4 means this. So AB is equals to, what I am getting is 9.81 minus 0.25 t. That is the equation 3. Now similarly, we'll go with block C. So block C has what? Weight down, which is WC. Tension about 2T. Acceleration is down, so inertial force will be above, which is MCAC. We'll just have a look here. WC down, 2T above, MCAC above, opposite to the acceleration. So here summation f of y equals to 0, positive. So WC down, 2T above, MCAC above, equals to 0. So AC is equals to, we are getting this. Similarly, if I'll further proceed, so AC is equals to 9.81 minus 0.33 T. Now we got the equation 2, equation 3, equation 4 in the form of AA is equals to AB is equals to AC. So these all AB, AC and AA will place it in this. What we'll be getting here, just have a look. So substituting 2, 3, 4 in 1. So AA plus AB plus AC is 2 times of AC equals to 0. We'll substitute each value. 9.81 minus 0.5 T, that is here. 9.81 minus 0.25 T, that is here. 2 times of 2 AC, it's 2 AC, so 2 into AC is 9.81 minus 0.33 T. It is mentioned here. When you solve this complete, we'll getting T is equals to 27.83 Newton. Okay, now this T value, if we'll substitute in this, you'll be getting AA. If we'll substitute in this, you'll be getting AB. If we'll substitute in this, you'll be getting AC. So that we have done it. Substituting T in equation 2, 3 and 4, we get AA. When we have substituted, we got negative sign. So if I'm getting a negative sign, I'm just converting into positive sign. And as we have considered all the AA, AB, AC downward direction, so here if it is negative means it is acting upward direction. I got AB other than 2.85 meter per second square. As it is positive means it is downward direction. AC I got is 0.63 meter per second square. As it is again positive means it is downward direction. Now the question arises, sir, you have told that whenever it is positive it is upward direction. I told it is correct, but here whatever we have assumed, if I am getting that value positive, then assumption is correct. If my assumption is wrong, I am getting negative sign and then I have to change the direction. With this, I hope you understood the complete problem. Thank you.